Hey, Algebra 2, we're going to learn how to solve exponential equations. All right, so it says rewrite using the same base. So hopefully we would all agree that 2 to the third equals 2 to the third. So if I erase that, and I made that an x, and I have 2 to the third equals 2 to the x, you would agree that x equals 3 because these 2's are the same, it's just the exponents. So what if I had 2 to the third equals 2 to the x plus 5? Like, well, okay, so these bases are equal, so I have to figure out what number should x be so that it equals 3. So if x was -2, -2 plus 5 equals 3, then x equals -2 in this instance. So the goal is if we can figure out how to write these numbers using the same base, then the exponents must be equal to each other. So on the first one, we have 2 to the x equals 8 to the third. Well, we don't have the same base anymore, so we can't just drop it and set the exponents equal. We're going to have to do some work and figure out, can I rewrite the big number as the smaller number to some exponent? And so you got to know that like 2 to the first is 2, 2 to the second's 4, 2 to the third is 8. Oh, hey, 2 to the third equals 8. So I can rewrite the 8 as 2 to the third. So this 8 right here is the same thing as 2 to the third. I just found a different way to represent it. And then the exponent, it came down. So now I have an exponent raised to an exponent. So you're supposed to know that when you have an exponent raised to an exponent, you have to multiply these. So 2 to the x equals 2 to the 9th. Now that I have my bases equal, I'm just going to drop them, and I set my exponents equal. So x equals 9. Let's learn how to check this because that was kind of random what just happened. Okay, so x equals 9, so I have 2 to the 9th. So I plug that into my calculator, and that is 512. 8 to the third, I plug that into my calculator, and that was also 512. So 9 must be the correct answer on here. The next one, I have 9 to the 2x minus 1 equals 3 to the 6x. So you generally want to look at the big number and ask yourself, can I rewrite that using a smaller base? Can I rewrite that as 3 to some exponent? So 3 to the 1 is 3, 3 to the second's 9, 3 to the third is 27. All right, so 3 to the second equals 9, so that's my winner here. So I have 3 to the second, and then I still have my existing exponent of 2x minus 1 equals 3 to the 6x. So we said that when you have an exponent raised to an exponent, you have to multiply. So since you had two terms right there, you have to distribute that 2 to both of them. 2 times 2x is 4x. 2 times -1 is -2. So now that my bases are equal, I'm going to drop them and I'm going to set my exponents equal and solve. That's an x, my bad. And so from here, I'm just going to do algebra. -2 equals 2x divided by 2, and x equals -1. So if you wanted to check this one, I would have 9 to the 2 times negative 2 minus 1. So just focus on the exponent right here, and let's figure out what this evaluates to. 2 times negative 2 is negative 4. Oh, I plugged the wrong number in. I was like, this is not working out. There we go. Okay. 2 times negative 2 is negative 2. Minus 1 is negative 3. So I plugged 9 to the negative 3 in my calculator, and it gave me a decimal answer of approximately 0.00137. Now I'm going to plug it into the one on the right. So I have 3 to the 6 times negative 1. That's negative 6. And then I plug that in my calculator, and I got 0.00137. So my two answers match, so I must have done it correctly. Okay. All right, so on the next one, I have a base of 64 and a base of 16. So I've been trying to figure out, can I write the bigger number as the smaller number to some exponent? Well, if you take 16 to the second power, I can't remember what it is, but it's way more than 64. So I'm going to have to change both of these. So sometimes you just have to play with numbers. When I see that both of these are even numbers, I know that I'm probably going to use either a 2 or a 4 as my base. So I'm going to try 4. So 4 to the first is 4. 4 to the second, 16. 4 to the third is 64. All right, so for the 16, I'm going to use 4 squared, and for the 64, I'm going to use 4 cubed. 4 cubed to the negative x minus 11 equals 4 squared to the 6x plus 2. Once again, I have an exponent to an exponent, so I'm going to distribute. So that gets me negative 3x minus 33. Distribute, and you get 12x plus 4. My bases are the same, so I'm going to drop them, and I'm going to set my exponents equal. Negative 3x minus 33 equals 12x plus 4. I'm going to do algebra and solve, so I'm going to add 3x to both sides. I'm going to subtract 4 from both sides. I get negative 37 equals 15x. I'm going to divide both sides by 15. And x equals negative 37/15. You can plug it in and check, and it actually does work. Backside. All right, so I have 27 raised to an exponent equals 1/27 raised to an exponent. All right, so anytime that you have fractions, you're going to have to fix them. So back in a previous chapter, I learned that if you have something raised to a negative exponent, you can fix it by sending it to the denominator. So this was implied to be over 1. You can fix negative exponents by flipping it and sending it downstairs. So I at least want to try to get rid of this fraction here. So I'm going to use the concept of negative exponents to fix this. Negative exponents will fix fractions. So I have 1/27. So this and this are kind of matching. And I want to put it up into the numerator. So therefore, that would be 27 to the negative 1. So you're going to fix fractions using negative exponents. 27 to the 4 minus 5x equals 27 to the negative 1 to the 6x minus 5. I'm going to distribute my negative. 27 to the 4 minus 5x equals 27 to the negative 6x plus 5. My bases are the same, so now I'm going to set my exponents equal. I would personally add 6x to both sides and subtract 4 from both sides. And you get x equals 1 for a good final answer on that. If you plugged it in and checked, it will work. In the next one, I have a fraction and that. Okay, so your first move is to fix your fraction. I'm going to do that with negative exponents. There is nothing to change on the right side yet. It's a good idea to distribute and clean this up first. So negative times x is negative x. Negative times negative is positive 5. So now that you did that one move, you should be able to handle this problem. We've done several of them now. So I want to see, can I write 25 as 5 to some power? And yes, I can. I'm going to rewrite 25 as 5 squared. When you have an exponent to an exponent, you're going to multiply them. So I'm going to distribute. 2 times 3 is 6x. 2 times 2 is 4. My bases are equal, so I'm going to drop them, and I'm going to set my exponents equal. Do algebra and solve for x. Add x to both sides. Subtract 4. 1 equals 7x. Divide both sides by 7. Get x equals 1/7 for a good final answer on that one. Try number 6 on your own. Check my notes. If you get negative 2/5, you have done it correctly. If not, check the notes. See you later.